Advances in semiconductor assembly and fabrication are offering medical device designers new options for smaller, more compact, and more sophisticated designs. As a medical device developer, do you worry about how these designs are executed by your contract manufacturing partner? There's good reason for concern in that modern surgical devices require a small, non-intrusive footprint, often with onboard chips, rigid or flexible substrates, and 3D stacked components. And there's often a requirement for integrated optical components and precision placement within plus or minus 5 microns in 3 axes. And the entire apparatus needs to be sterilizable and hermetic. A recent project at Promax involved a new approach to endoscope design. This is a traditional device used for doing laparoscopic surgery. The black cable goes from the sensor head that goes inside the body to a screen or an optical viewer and is the traditional method that's been used for decades to look inside the body. In a traditional endoscope design, there's an optical chain that uses a series of optical elements, lenses, mirrors, image conduits, to carry the image from the lens to a camera or an optical eyepiece that the surgeon looks through to see what's going on. So you have a relatively large device with both a good deal of complexity and issues with image quality where the surgeon is essentially working through the eyepiece of a microscope. So we had a customer come to us and say, hey, we'd like to build an assembly that would replace this functionality with a miniature, high-definition stereoscopic TV camera. Help us figure out how to make such a thing. Can we move the camera to the tip of the endoscope? This would create a sharper image, a simpler optical chain, and the device would be smaller, thinner, and easier to handle. So that was the original project that we got started with. And this is a more extraordinary version of the concept, a capsule endoscope, made with all the optics, image sensors, and electronics stuffed into it that a person literally swallows. And this device goes through the intestinal system and sends out either an RF signal or records a video record internally of what the image looks like as it passes through the digestive tract. So such a device must have a series of unique characteristics. It has to be able to be assembled, be very robust, and take some amount of physical and mechanical abuse. And it needs to withstand sterilization. This requires working through a portfolio of fabrication and assembly capabilities to develop the optimal approach to fabricate such a device. A key feature was the use of 3D assembly of the optical and semiconductor components into a stacked configuration to pack more functionality into a smaller space, and a range of assembly technologies to fabricate the camera assembly. Techniques such as flip chip, waterfall bonding, and even more advanced techniques such as on-chip through-silicon vias or TSVs. These are vertical electrical connections designed to pass completely through a silicon wafer to facilitate three-dimensional assembly. And this is what the final 3D stacked camera assembly for the endoscope looked like. There's a lens on top of the cover glass and an image sensor, which along with the lens creates a miniature video camera. The entire assembly is just 8 millimeters across, an assembly with incredibly close dimensional tolerances that's the size of the eraser on the end of a pencil, forming a high-definition stereoscopic camera in full color. The entire assembly is hermetically sealed and can withstand autoclave sterilization. A successful design has got to work, must be robust, and have good economics, and we are currently fabricating these units for the customer at our primary facility in Silicon Valley. So medical device manufacturing is characterized by a few key factors: being able to operate in a tight regulatory environment, lifetime bill of material and process documentation requirements, and demanding layout and size control involving mixed assembly processes and the development of stable automated processes. And once such a process has been fully developed and properly documented, it remains unchanged for the life of the product due to the costs associated with making any modifications. At Promex, we specialize in the fabrication of complex medical and biotech devices that incorporate microelectronics. We understand your concerns and issues regarding the regulatory processes and the unique engineering demands required for medical devices and can bring a wide range of capabilities to help clients turn designs into manufactured assemblies that meet the client's technical, regulatory, time to market, and economic constraints. If we can help with your fabrication needs or just answer an engineering question, please use the form below to reach out to someone on our engineering staff or on the business side.